All right. Oops. Actually got the wrong year here. This is 2016. Okay, I've got free response questions from Physics A this time around again, since we finished all the Physics C. Over on AP Classroom, though, I've assigned the International Practice Test from 2017. And I'd like you to do that instead for homework, since we've got a week left before the exam. I
Is it
will
uh-huh.
I will send you the scoring guides for the rest of the AB exam for 2016, just so you've got it to study for your AB part too.
Okay.
Okay.
And it's in AP classroom?
Yes. AP Classroom was just assigned 10 minutes ago. 2017 International Practice Exam.
2017. Wait. It's killing now. Mm, oh, yeah, I see three FIQs. I
Awesome.
mean, 3 years.
Okay, so let's go ahead and get started.
Uh-huh.
Um, so we've got this wooden wheel of a mass m, which has this rim with spokes rolling down a ramp with an angle of theta, as shown below. Um, the ramp exerts a force of static friction on the wheel, so the wheels roll without slipping.
Uh-huh.
We need to draw and label the forces that are acting on the wheel as it rolls down the ramp, which is the dashed line here. How are you going to draw your forces?
Oh, so we have normal force first, which is perpendicular to the track.
Okay, normal force perpendicular to the surface. Perfect. Here, force normal. Okay, what else?
And friction going up, but it's along the track.
Okay, friction going up along the track. So something like this. A force of friction.
And gravity, just straight downward.
Okay.
No, wait, yeah, it's
Wait,
not
so
gravity.
I'm just going to keep that as mg.
Mhm.
Okay. Then, as the wheels roll down the ramp, what force will cause a change in the angular velocity with respect to the center of mass, and then briefly explain.
Friction,
Okay, friction, you're right. Why?
because if there is friction, then the um, what is it? The wheel will rotate without slipping. Wait, and then how do I explain it? So, and then we know omega is V over R.
I'm going to give you a hint.
Uh,
I want you to use the
mhm.
word torque in your answer.
Oh, because the only torque exerted on the wheel is friction.
That's it. The frictional force is the only force that exerts a torque with respect to the,
Center of the mass.
yeah. I was just going to write wheel, but I like that a lot better actually. So the center of mass of the wheel.
Uh-huh.
Okay. I probably didn't give myself enough space, so I'm going to have to draw a weird arrow here. But for this angle, the force of friction exerted on the wheel is less than the maximum possible static friction force. Instead, the magnitude of the force of static friction exerted on the wheel is 40% of the magnitude of the force component directed opposite to the force of friction. Derive an equation for the linear acceleration of the wheel's center in terms of mass, theta, and physical constants.
Wow, okay. For this ramp, the force is, so basically if we just write the formula, then it's MA is equal to mg sine theta minus friction.
Okay.
Because we finding the
Okay. Mg sine theta minus our force of friction is equal to our total force. So that's going to be net acceleration then.
Yeah.
Okay.
But it says the force of friction exerted on the wheel is less than the maximum possible static friction. Instead, the magnitude of the force of static friction exerted. I don't understand. The magnitude of the force of static friction exerted on the wheel is 40%. So, the magnitude of the force of static friction is 40% of the force.
40% of the force component that is opposite to the force of friction. So what's the force? Oh, go for it.
Oh, mg mg sine theta is the opposite force. Oh, so 40% of mg sine theta is the frictional force?
That's it.
Oh, okay. So mg sine theta minus 0.4 mg sine theta?
Perfect.
Oh, okay.
That was really hard in terms of English, so he did really well.
Yeah.
Okay, so if I subtract these, that gives me our net acceleration is equal to 0.6 times my mass g sine theta divided by mass.
M. Yeah.
And those are the same mass, so we can cancel. So our net acceleration then is 0.6 g sine theta.
Yeah.
Just double check. We need our linear acceleration in terms of mass, theta. Okay, we've got theta and any physical constants, so we're okay. Right?
A block of ice also mass m released from the rest from the same height. Which object reaches the bottom of the ramp with the greatest speed? Neither. Both reach the bottom with the same speed. Because the force only acting on the object, no, the velocity is determined by theta and g, not the mass of the object. Wait. Is it correct?
No.
Oh wait, this one? Oh, it's just ice, right?
Yes.
Oh, I thought it's real. So ice, there is no friction, then the block will reach the greatest speed.
Okay, the block will be greatest speed.
there is no friction.
Right. The wheel still experiences a counteracting force of friction. So the block has a greater net force and acceleration.
Yep.
Okay, can you rewrite this explanation in terms of energy instead?
So for the wheel, energy there is oh, okay, so so initial mechanical energy is potential energy, but final there is friction. No, there is rotational kinetic energy and translational kinetic energy for the wheel.
For the wheel, okay.
But for the ice, there is only translational kinetic energy.
Perfect. For the wheel, potential energy is converted into rotational and translational
kinetic energy.
But for the block, is only converted to translational. Trying to write really fast on the screen. This is getting harder and harder to read. But I do want you to have this for your notes later. Okay. Therefore, the block is faster. Oh, and I guess that's it. It was faster than I thought. I think these physics 1 questions are only out of 12 points instead of 15. There tends to be a little bit less to them, but they still take a little bit longer because we have to write out the explanations. At least for me.
Yeah.
Okay, so I'm going to send you the scoring guides in case you want to keep studying on your own, but the homework is going to be taken through AP Classroom for that 2017 international exam.
Oh, only 2017?
Yes.
Okay. Oh. If it was normal school day, then I already finished 2 AP classes. I mean 2 AP tests. Because originally it was May 5th and May 4th for Physics C and Calculus BC.
It's just one more week, so we don't have too much longer. All right, any other questions or stuff you want to talk about?
Nope.
Okay, then I'll see you tomorrow for Calc 2.
Bye bye.
Goodbye. Have a good one.